Okay, so today we are going to continue on with section 2. Today's notes are labeled as chapter P, section 2, but it's part B. Today we're going to start talking about negative exponents and rational exponents. Really what a rational exponent is, it's a fraction exponent. So let's go ahead and first look at what a negative exponent will do, and also dividing with exponents. So when you have exponential expressions with a negative exponent, what we're going to do is sort of think about reciprocal. We're going to move from the numerator to the denominator or vice versa. So sort of think reciprocal. When you see a negative exponent, it does not make the answer negative. That's the key thing to remember. What it's doing is it's making it into its reciprocal, or making it into a fraction. So for example, here where we have a to the nth power, or negative n power, really all we're doing is taking this expression and taking away the negative sign and moving it to the bottom of a fraction. Now, if you'd rather think about it as a to the negative n being with a 1 here, and you want to think reciprocal, then you just flip it and take away the negative sign. So this is what this will simplify to when it's a negative exponent. Now, if it's negative in the bottom, again, we're thinking reciprocal here. And to simplify this, you would flip it and then make the power negative. Whenever there's a 1 in the denominator, the answer is just whatever's left in the numerator. When we divide exponential expressions, if the base is the same, we're going to take the exponents and subtract them. So in P.2a, we talked about multiplying exponents with the same base, and we added them. Now for division, we subtract. So just to show you an example, let's say I have 2 to the 7th power divided by 2 to the 5th. Notice the bases are the same, so all I have to do is take those exponents, subtract them. 7 minus 5 is 2, and you get 4. Because if you think about this, if I were to write 2 to the 7th power, 3, 4, 5, 6, 7, and then write 2 to the 5th on the bottom, notice I could simplify this, because 2 divided by 2 is 1, 2 divided by 2 is 1, is 1, is 1, is 1, and notice the only thing that was left was to multiply 2 times 2, and you get 4. So if you ever blank out and you're like, oh no, what do I do when I divide exponents? What do I do with those exponents? Expand it out and then try to simplify it. But the bottom line, when you divide exponential expressions, you just take the exponents and subtract them. Now let's say it was the other way. Let's say instead it was 2 to the 5th divided by 2 to the 7th. Now this is where it can get tricky. Be careful with your signs. So what I'm going to be doing here is 2 raised to the 5 minus 7 power, and then we end up getting 2 to the negative 2 power. And again, when it's a negative power, it moves to the bottom underneath a 1, and then the exponent becomes positive, and this would be 1/4. Again, if we did the same scenario where we wrote all the 2's, and then if you canceled them, and remember when we're canceling these, really what we're doing is dividing 2 by 2. So really what's left behind here is a 1. So then anything 1 times 1 times 1 is 1, and then the 2 times 2 is 4, and then you can see how that division actually works. Now, just to clarify also the negative exponents and how you can think reciprocal, let me show you a couple examples of those with some numbers. So let's say we have 5 to the negative 2 power, and it says to simplify it. Again, remember you can always turn a whole number into a fraction by putting a 1. So then to evaluate this negative exponent, think reciprocal, flip it, and now we can evaluate it, and it's 1 over 25. If it's negative in the bottom already, again, just flip it, and now we would get 25 over 1, or 25. So if you have a negative exponent, you just move it to its opposite spot. If it's negative in the top, put it in the bottom. If it's negative in the bottom, move it to the top. Let's try some examples. So the first one, we have 4 to the negative 2 power. So if you want to think about it as the reciprocal, we could do 4 to the negative 2 power. We could add a 1. And now we think reciprocal, flip it, and it's 1 over 16. Just remember, as soon as you identify that your power or your exponent is negative, remember that this is turning it into a fraction. It's not making the number negative. The next one, same thing, even though it's not a number, we can take this. Again, we could think of it like this to begin with, flip it, and now we're done. We don't know what x is, so there's nothing to evaluate. Now the next one, be very careful. Notice this negative 4 power, it's only on the x. It is not on the 2. So only thing that's going to move to the denominator is the x. So the 2 is going to stay in the numerator, and the x will move to the denominator. If there were parentheses around this, then the whole thing would move to the denominator. And then we would evaluate 2 to the 4th and x to the 4th, and this would become 1 over 16x to the 4th. So be very careful if there's no parentheses around the variable that has the negative exponent. Now, here's where that reciprocal thinking is going to really help out. So whenever I see a fraction that is raised to a negative exponent, again, I'm thinking reciprocal, so I'm just going to flip it, make the exponent positive, and now I can evaluate that. So it would become 5 to the 3rd and 2 to the 3rd. Or again, you could think of it as 5 over 2, 5 over 2. Multiply all this out. 5 to the 3rd power is 125. 2 to the 3rd power is 8. I am okay with you leaving it improper. We don't need to make it a mixed number or a decimal. Now, the last two examples on this slide, they look very much the same, but notice one has a parentheses and one does not. So we talked about negative numbers being raised to a power. It makes a difference if there's a parentheses. So for example here, again, if you'd like to think of this having a 1 underneath it, we can think reciprocal here, flip it, and now evaluate. Negative 4 times negative 4 gives me positive 16. However, on the next one, that negative sign is not attached to that 4. So what we can think about this as being as negative 1 which is just for the negative sign here. And then the 4 is what has the negative 2 power. So again, the negative exponent is what's going to move to the denominator, and the 1 will stay in the top. And then this becomes negative 1 over positive 16. Now, one other thing I want to show you is also what happens if you have a negative sign in the top, or if it's in the denominator, or if it's in front of the whole fraction. All three of these things mean the same thing. The only difference is when you have a negative in the top and a negative in the bottom, because a negative divided by a negative is a positive. So whenever you're doing a problem, if you end up with a negative in the numerator and a negative in the denominator, just remember that is going to simplify to a positive fraction. But if whenever you're doing problems, if the negative sign ends up in the top of the fraction or the bottom, or even if it's given to you in front, all three of these things mean the same thing. It doesn't matter the location of the negative sign. Everybody good there? All right, let's try some more examples. So again, be very careful if there's no parentheses. For example, on number 7 here, notice the negative 3 is only on the y. That is the only part of this expression that's going to move to the denominator. The x has a positive 1, it stays in the top, but then the y will move to the denominator. Number 8, this is where we're going to just simplify the fraction. So we could simplify the 4 over 16. That's going to simplify to 1 over 4. And for the variable portion, the bases, both x, so I subtract the exponents.
Correction, Sophia Perez and Matt Hernandez. Please report to student services. Sophia Perez and Matt Hernandez. Report to student services. Thank you.
Now, again, remember when you are subtracting the exponents for division, when your answer of your subtraction problem is negative, then that variable is written in the denominator. I don't need to show that it has the first power. It's assumed to be a 1. Let's try number 9. So for this one, I just need to move my negatives to the denominator. So the x to the negative 3 is going to move, and so is the z to the negative 4. The 4 is a positive, you can assume it's got an exponent of 1. The y has a positive exponent of 2, so that will stay in the numerator. So 4y squared, and then the x will move to the denominator because it has a negative exponent, and so will the z. And you're done. Now, the next one, we've got different ways that we can tackle this one. So I'm going to show you both ways. So what we can do here is we can either choose to move the negative exponents to its opposite spot, and then we're going to end up having to probably multiply, or we can leave them where they are and do a subtraction problem. So let me show you the first way where we're going to move the negatives. So notice the x raised to the negative 2 power needs to go down. And then this y to the negative 3 needs to go up. The rest of the stuff is staying in their same spots. So the 3 stays here. And let me do it in a different color, sorry. So 3, and then the x squared is going to go to the bottom. So I also have the x to the 4th that didn't move. The x to the negative 2 is going to the bottom. The y to the 4th stayed there. And then the red y to the negative 3 moves to the top. Now that I've rearranged the negative exponents, now I use my rule for multiplying. So I'm going to multiply the two bases that are the same, the two y's. Remember, when you do that, you add the exponents. So this will become y to the 4 plus 3. So then this becomes 3y to the 7th. And then the denominator becomes x to the 4 plus 2, which is x to the 6th. That's one way. The other way, I'll show you the other, and I don't care which method you're going to use to simplify this. Let me rewrite the problem. 3, negative 2, y 4, x to the 4th, y to the negative 3. The other way to do it is leave the exponents alone, don't move them. So if we work with the x's, these are the same base, and then if we work with the y's, we can also do it this way. We could take the 3, leave it alone. The x is going to become negative 2 minus 4 power. So then this will become 3x to the negative 6. And then for the y, 4 minus negative 3. You do your keep, flip, change here, and it becomes 4 to the, y to the 4 plus 3. So then this becomes y to the 7th. Now, when you're doing any kind of subtraction, if your power, or the power becomes negative, remember we need to move it. So again, we would get 3y to the 7th stays in the top, but because the x has the negative power, it moves to the bottom. So you could use either method, I don't care, to simplify these. Let's try some more examples. Pretty good on this slide? All right, next. So we've got some practice here with some division. They both have a base of 5. So remember, when you divide, we take those exponents and subtract them. 9 minus 7 is 2. So 5 squared is 25. Same thing on number 12. They both have a base of x. So I'm going to just do x raised to the 14 minus 10 power, which gives me x to the 4th power. Numbers 13 and 14 are still the same, just be careful with the signs. So for number 13, it's x to the 10 minus 14 power, which gives me x to the negative 4 power. And remember, when you have a negative exponent, think reciprocal and put it in the opposite spot so it moves to the bottom. Same thing on 14. The bases are both 7. Now watch the signs. 5 minus negative 3. And if your teacher taught you keep, change, flip, or stay, change, change, however your teacher taught you how to subtract integers, this is what we do here. So this becomes 7 to the 5 plus 3, or 7 to the 8th power. So if it says leave it in exponential form, we're done. If it asks you to evaluate, we would figure out what 7 to the 8th power was. Next one. Again, we can do this two different ways. We can either choose to just subtract the exponents where they are, or we could flip their spots. So I could divide the coefficients. 15 divided by 5 is 3. And then if I use the method of just subtracting the powers because they have the same base, this really becomes -4 plus 8. So then this becomes 3x to the 4th. If you'd rather flip the spaces and put the 8 in the top and the 4 in the bottom, we're still going to have to subtract in the end. So it's almost better just to subtract the powers as it is. Number 16, same thing. I can simplify the coefficients, the 15 over 25. That's going to reduce to 3/5. Now, if I want to just subtract the powers, I could do the A. The A is -5 minus -2. Again, a keep flip change, or a stay change change. And this will become A to the -3. Remember, when you get a negative, this gets written in the denominator. Then if we do the B's, B to the -1 minus 4, which gives me B to the -5. Again, it's a negative exponent. It needs to be moved to the bottom. So that's just taking the powers as they are and subtracting them. Again, if you'd rather move the negatives to their spot, you can. Again, we would still have to do some kind of operation after they're moved. We're still going to have to subtract. So honestly, I think it's almost easier. As soon as you see you have something that is the same base, just take those powers, subtract them. Just be careful with the integer rules. Okay? Now, if you'd prefer to move it and then subtract it, you can. So the 15 over 25 still reduces to 3/5. But if I switch the spots and move the A squared to the top, the A to the 5th to the bottom, move the B to the -1 power to the bottom, and B to the 4th, it's already positive. Then we still have to go back and subtract these and add these. So once I did the subtraction here, this would give me A to the 2 minus 5, which is -3, which tells me it's in the bottom. And for the blue, I would add them, and it's positive. So it stays where it is. So again, either way, move that to the bottom, and that stays where it is. All right, we'll try the next slide, and that will cover the division and the negative exponents. We can try and do some of the rational. We'll see how it goes. Last slide for the negative exponents. All right, so here, different ways we can tackle this. The first thing I'm going to take care of is the negative sign. So I'm just going to flip this to its reciprocal and leave the exponent as a 2. So I'm going to flip it upside down for A, and inside here, everything still stays the same. All I'm doing is flipping upside down. Now, for your next step, what I can do is take care of the negative exponents. So if you like to move the negatives to their spots, we can do that. So I can move the -3 exponent down to the bottom. So then now it'll become 4b to the 4th, -3, and I've got an a to the 1st, a to the 3rd now, and then the b, and it's still squared. Now I can add these two powers because they're being multiplied. So then this stays the same. And now it'll become a to the fourth b, and it's squared. I could have also at the same time probably, let's take care of this b. So this is b to the fourth divided by b to the first. Let's go ahead and take care of that and make that a b to the third. Let's just get rid of that bottom b. If you wanted to do it in its own step, you can do that as well. All right, so now that I have everything simplified in the parentheses, now I can square that fraction. So again, you can either think of it as writing it 2 times and then multiplying this, or just realize that this power of 2 needs to go on everything. So either way, so we would do 4 times 4, and that will give me 16. And then b to the third times b to the third, we add the powers. -3 times -3 is positive 9. And then a to the fourth times a to the fourth is a to the eighth. Remember, you add those exponents. So this would be the final answer for number 17. Then the last example for the negative exponents. Again, the first thing I'm going to take care of is the negative. So I'm going to go ahead and flip it. So I'm going to flip it as 9xz, and everything stays with the same exponents. All I'm doing is taking care of the negative sign on this power that's here. Now again, I can simplify within the parentheses. Notice here, x divided by x is going to give me a 1. So this is gone. Then for the y's, there's no y in the numerator and there's no z in the denominator. So all I'm going to do is, for that, I'm going to switch their spots. So because z is negative in the numerator, it's going to move to the denominator. And the y is negative in the bottom, so it's going to go to the top. And now I can apply the cubed, or the third power. So now I'm going to go ahead and I can also simplify the 9 over -3. Let me go ahead and do that as well. So then this becomes -3 y squared over z raised to the third power. -3 to the third power gives me -27. And then y squared raised to the third power is y to the 6th. And then the third power also goes on the z. And that's your final answer. All right.